Future Builder. The Future Builder widget in Flutter is a powerful tool designed to handle asynchronous operations, making it easy to fetch and display data without blocking the main thread. As applications become more complex, the need for handling data that is fetched over a network or computed in the background increases. This is where Future Builder comes into play, allowing developers to build UIs that respond to changes in data state seamlessly. The Future Builder widget takes a future as input, which is a representation of a computation that will complete at some point in the future. When the future is passed to the Future Builder, it begins listening for the result. The Future Builder requires a builder function, which is called whenever the state of the future changes. This function provides two main parameters, build context and async snapshot. The async snapshot object contains the current state of the future, which can be one of three states: waiting, active, or done. When the future is still loading, the connection state of the snapshot will be connection state.waiting, allowing developers to show a loading spinner or some placeholder content. This is particularly useful for creating responsive UIs where users expect some indication of ongoing processes. As the future resolves, the builder function is triggered again, and the snapshot is updated with the result. If the future completes successfully, the snapshot's hasData property will be true, and the data can be accessed via the data property of the snapshot. This data can then be used to update the UI accordingly, whether it's displaying a list of items fetched from an API, showing user details, or presenting weather data. On the other hand, if the future encounters an error, the snapshot's hasError property will be true, allowing developers to handle errors gracefully by displaying an error message or a fallback UI. One of the main advantages of using Future Builder is its built-in mechanism to manage loading states and error handling. This reduces boilerplate code and simplifies the overall structure of the app. Instead of manually managing the loading state and error state with separate variables and conditional statements, Future Builder centralizes this logic, making the code cleaner and more maintainable. Developers can focus on what needs to be displayed based on the current state of the future, which enhances code readability and efficiency. The Future Builder widget is especially useful in scenarios where data needs to be fetched from a remote server. For example, when building a weather application, a Future Builder can be employed to fetch current weather data. In the builder function, you might display a circular progress indicator while the data is loading, and once the data is available, you can present the temperature, humidity, and weather conditions. If an error occurs during the data fetching, you can display a friendly error message, guiding the user on what to do next. Using Future Builder effectively also involves understanding the life cycle of the widget and how it interacts with the app's state. Since Future Builder rebuilds its UI whenever the future changes, developers need to be cautious about the future they pass in. If the future is recreated on every rebuild, it can lead to an infinite loop of loading states. To avoid this, it's often best to create the future once in the widget's lifecycle methods, such as initState, and use a state variable to hold the future. This ensures that the Future Builder remains efficient and avoids unnecessary network calls. In conclusion, Future Builder is a versatile widget in Flutter that simplifies the process of working with asynchronous data. By managing loading states and error handling internally, it allows developers to focus on building responsive user interfaces. Whether fetching data from an API or performing long-running computations, Future Builder provides a structured way to handle the complexity of asynchronous programming in Flutter applications. Understanding and utilizing Future Builder effectively can significantly enhance the quality and responsiveness of your Flutter apps. Safe Area. The Safe Area widget in Flutter is a vital component for ensuring that your user interface adapts gracefully to different device configurations, particularly those with notches, rounded corners, and other screen obstructions. As mobile devices evolve, manufacturers are increasingly designing phones with unique shapes and display features, which can lead to content being obscured if not handled properly. The Safe Area widget addresses this issue by automatically adjusting its child widget's position to avoid areas of the screen that could be obstructed. It provides a straightforward solution to maintain visual consistency across various devices and screen sizes. When you wrap a widget with a safe area, it calculates the padding needed to ensure that the widget is not obscured by system UI elements, such as the status bar, navigation bar, or any device-specific features like a notch. By default, Safe Area applies padding to all sides of the widget, but you can customize which sides to include by using the left, top, right, and bottom properties. This level of customization allows developers to fine-tune their layouts to suit specific design requirements while still benefiting from the automatic padding adjustments. Using Safe Area is particularly important for applications targeting multiple platforms, including Android and iOS. The two platforms handle screen obstructions differently. For instance, the iPhone has a prominent notch at the top, while many Android devices have varying status bar heights. By incorporating Safe Area, developers can create a single code base that adapts to these differences, providing a seamless experience for users regardless of their device. This reduces the need for platform-specific code and simplifies the development process. One common use case for Safe Area is in applications with navigation bars or tabs. If your app includes a bottom navigation bar, it's crucial to ensure that the main content area is not obscured by the navigation bar, especially on devices with smaller screens. Wrapping the main content of the screen in a safe area helps achieve this, ensuring that the user can interact with all available content without obstruction. Another scenario where Safe Area proves beneficial is in applications that display images or graphics. Developers often want to make the best use of available screen space, and neglecting to account for safe areas can result in critical parts of images being cut off or obscured. By using Safe Area, you can guarantee that your images are displayed within visible bounds, improving the overall aesthetics of your app. It's also worth noting that Safe Area is not just about avoiding visual obstructions, it also contributes to user experience by ensuring touchable areas are accessible. When users interact with your app, they expect certain UI elements to be fully reachable and functional. By applying Safe Area, you ensure that buttons, sliders, and other interactive elements are placed within safe zones, preventing accidental touches or frustration due to obscured UI elements. While Safe Area is highly effective, developers should use it judiciously. Overusing Safe Area can lead to unnecessary padding and a less than optimal layout. In cases where you know your layout will not be affected by screen obstructions, it's often better to forego the Safe Area and allow widgets to use the full screen real estate. Additionally, testing your app on multiple devices is crucial to ensure that the UI behaves as expected across various screen configurations. In summary, the Safe Area widget is an essential tool in Flutter for creating adaptive and responsive user interfaces. By automatically adjusting padding to accommodate screen obstructions, it allows developers to build applications that look great on any device. Whether you are developing a complex app with multiple screens or a simple layout, incorporating Safe Area will enhance user experience and ensure that your content remains visible and accessible. Circular Progress Indicator. The Circular Progress Indicator widget in Flutter is a widely used component that provides users with visual feedback about ongoing processes, particularly tasks that take time to complete, such as loading data from a server, performing calculations, or processing user input. This widget is an essential part of modern user interfaces, as it helps manage user expectations by indicating that a task is in progress. When users see a circular progress indicator, they understand that the application is working on something, which enhances the overall experience and reduces frustration that might arise from uncertainty about whether the app is responsive or not. The circular progress indicator can be displayed in two primary modes, indeterminate and determinate. The indeterminate mode is the default and is used when the duration of the task is unknown. For example, when fetching data from a remote API, you typically cannot predict how long the request will take, so displaying an indeterminate progress indicator provides users with a clear indication that something is happening. The spinner continues to animate until the task completes, after which you can remove it or replace it with the resulting data. On the other hand, the determinate mode is used when you can track the progress of a task. In this case, the circular progress indicator can be configured with a value property that ranges from 0.0 to 1.0, representing the progress of the task. This is particularly useful for tasks such as file uploads or downloads, where you can calculate the percentage of completion and provide users with more specific feedback. By using a determinate indicator, you not only keep users informed but also help them gauge how much longer they might need to wait. Customizing the appearance of the circular progress indicator is straightforward.
The end.